Oh, y'all, let me pull that chat up. Oh, y'all, so this is 2.1 in its graphs of equations. Alrighty, now, the big thing on this is not going to be actually drawing the graphs on paper. It's going to be graphing these things in MATLAB, okay? So what we want to do is I'm going to pull up a question from MATLAB for us to graph. So y'all, my first one here. Um, so y'all are familiar with drawing a straight line, but like I said, we're going to be drawing parabolas and absolute value and stuff. So the main method of graphing we want to use in here, so graphing equations, we want to use what I call the table method. Okay? So the table method is where you're going to set up a t-table. All right, so a t-table is going to have your x's and your y. So the basic way you drew lines was using a table. At that point, you're going to pick, I usually pick at least three x values. So I'm going to pick at least three x values. What I'm going to do then is take the three x values and go one by one and plug them into the equation. So plug each x value into the equation to find the y values. Okay, so I'm going to plug each of my x's into my equation. That'll give me some y values for each x. All right, once I've done that, I can then draw the graph. Okay, now, as we go through these, watch what type of equation I got, and then look at what the graph pictures will look like, okay? So like I said, we will start out with straight lines for the first two. And all this will say graph the equation by plotting points. Which is what we'll do by setting up our table. Each of these x's and y's is going to give us what we call an ordered pair. So remember, your ordered pairs will be your x's and your y. The x coordinates go left or right on the graph according to the sign. If it's negative, we move left. If the x's are positive, we move right. Then you go to the y value. The y's can either move up or down. If the y value is positive, we move up. If the y values are negative, we will move down. Okay? So treat each x and y as an ordered pair. So y'all, my very first one here. And they've already got this one solved. Y equals 4/3 x minus 3. So I'm going to set my little table up, and then I'm going to find the corresponding y values. Now, here's the thing on this one. I'm sort of picky what x's I use when I got fractions in front of that x. Okay? Now, I will use 0 for my x. Now, in order to avoid having to graph fractions or decimals, the easiest thing would be to pick x values that can sort of eliminate that fraction's bottom. So y'all, what I mean by that, I'm going to choose 3 for one of my x's. Because if I put a 3 here, those 3's would cancel out when I multiply that. So that sort of gets rid of the fraction. Another number I would use would probably be a 6 or even a -3 or a -6. When you got a fraction like this, you want to pick x values that are multiples of that 3, okay? So 3, 6, 9, 12, numbers like that would work. And they can be positive or negative. So y'all, let me show you how this is going to work. So I picked a 0. I'm going to put 0 in for x. Well, y'all look at that. 4/3 times 0 is going to be 0. So I'm going to get 0 minus 3. And 0 minus 3 is a -3. So that's my first point I can plot, 0, -3. Now, the second one, I'm going to put the 3 in for the x. So that's going to give me y equals 4/3 times 3 minus 3. All right, so what happens, and you can treat the 3 like a fraction when you're multiplying by putting a 1 under it. But what happens here is this 3 on top divides by that 3, making that a 1. So I just divided it out. So this is basically a 4 times 1, which is 4, and then minus my 3. And then y'all, 4 minus 3 is 1. Okay? So now let me show you what happens when I put a 6 in. I get y equals 4/3 times 6 minus 3. So treat that like it's a 6/1 still. But y'all notice here, if I take the 6 and divide by the 3, that actually gives me a 2 this time. So I'm just dividing them out. That's going to give me a 2. Well, here, 4 times 2 gives you 8. And then it's minus 3. And 8 minus 3 is 5. Okay. Now, that gives me a 5 right there. If you pick numbers that are not multiples of 3, say if you put a 5 here, well, y'all, 5 don't divide by 3. So that's going to give you a fraction when you try to work that out. And then you would have to try to plot a fraction on that. So if you want to avoid those fractions, um, use numbers that have a multiple of 3. And I'm going to try something here until I get my screen fixed. So y'all watch this. To graph on this, you hit the Y equal button on the top left corner. So let me clear everything. Now let me see if I can focus that a little better. All right, so you can see that a little better now. So put into fraction. Now, if you want it to look like a fraction, if you hit this green button and then you hit the Y equals, N over D, if you hit enter on that, it brings up a fraction. So I had a 4 on top, arrow down and get my 3, arrow right. I'm going to put in my x. And then I had what? -3. So that's your equation. Now, if I hit the blue button and the graph button, I can pull the table up. So second graph, it pulls up my table. So you see, whoops, let me go to -3. At -3, you get a -7. So -3 is a multiple of 3. But y'all look at -2. I get 17 over 3. If I go to -1, I get 13 over 3. But here at 0, I ended up with a -3. But watch this. Fraction at 1, fraction at 2. But here's 3. We got a 1 like we got. And then 4 will be a fraction, 5 will be a fraction. 6 is a multiple of 3, so that gave us a 5 like we got. So you'll notice that all the multiples of 3 give you nice whole numbers that you can graph, okay? All right, so now I want to look at the graph. If you hit the graph button, you can actually see what the graph looks like. So y'all see it's just a straight line going uphill to the right. Okay? So the trick is graphing this thing in MATLAB. Now, like I said, you could hit second graph and plot 2 of these points in MATLAB, okay? So y'all let me show you this. This graph here, anytime you got an X like this, the graph is going to be a straight line. In MATLAB, we're going to use what they call a 2-point line tool. Okay, so I'm going to go to MATLAB and show you how to graph these. All right, so this won't be the same problem I'm using, but I'm going to use the numbers we had, okay? So you would click to enlarge graph. Over here, the second tool on the top, it's got 2 dots on a straight line. You'll click that, and then you're going to plot the 2 points. So my first point was a 0, -3. So y'all always start in the center. Now look in that little yellow band up there. That little yellow band, as I move the cursor, it changes the numbers up there for us, okay? So I had 0, -3. So I went straight down to -3. I clicked that. And then I had 3, 1. So starting back at the center, I would go right to 3 and then up 1. So yeah, there's that little uphill graph going to the right. And then we save that. Okay. So once you'll graph it, you'll come down here in the bottom right that says check answer. So click that answer and then move on to the next problem, okay? I'm not going to check this one because it was different numbers than I used though, okay? All right, y'all, so question on that, graphing that straight line.
No, sir.
All righty, so let me get us going on, let's see what this number 2 has here. So y'all, same thing on this one. So what I'll do on this one, since it's going to be another straight line, I'm going to show you how to solve this one. So that's 8y plus 4x equals 4. All right, so let me go back to my pad. So this one, if you're going to use the calculator or sort of help you figure out what points you want to use, since this one's not solved for the y, that would be our first step is to try to solve it for the y. So we're going to solve for the y. So if you're going to solve this for y, our first step is to get the 8y by itself. So since this 4x is being added, what we're going to do to move it to the other side, we're going to subtract it from both sides. So we'll come in here and subtract 4x from both sides. So that's going to put my 8y over here. That cancels on the left side. Now notice here, you got a 4 and you got a negative 4x. Those are not like terms. So since these aren't like terms, I'm just going to put down my negative 4x and then bring down my positive 4. So you can do negative 4x plus 4, or you could do 4 minus 4x. Either way don't matter. I usually like my x's first, but y'all, like I said, either way it don't matter, okay? All right. So now that's an 8y. We want that to be a 1y when we're solving it. So since this 8 is being multiplied by the y, if I want to make that into a 1y, I would undo the multiplying by dividing by the 8. Now, when you divide, every term has to be divided. So division and multiplication have to be done to every single part of your equation, okay? All right, y'all, so the reason I did that, 8 divided by 8 makes that a 1. So I got 1y. Now, negative 4 will not divide by 8, but this will reduce. So negative 4 over 8 will reduce to a negative 1/2 x. And then this one, 4 over 8, reduces to a positive 1/2. So what I'm doing to reduce these fractions, 4 and 8, they both divide by 4. So I just divided the top by 4 and the bottom by 4. So the 4 divided by 4 gave me a 1 on top. 8 divided by 4 gave me the 2 on the bottom. All right, y'all. So here is your equation. So at that point, so this one, since this number looks like a fraction, you're pretty much going to be graphing a fraction on this one. Unless you use this calculator. So let me show you. I'm going to go to y equals, clear this out. All right, so since that's a fraction, I got negative. I'm going to hit the alpha y equals and enter. And that was a 1 over 2. L right, put in your x. And then it was plus. I got another fraction, so I'm going to hit alpha y equals and enter. And make that a 1 over 2. All right, so what we wanted was some points. So if you hit second graph, look, most of these have, so I can plot that negative 1, 1 right there. That'd be a good point. Let's see if I come down here at 1, 0 is a good point. And then it looks like at 3, I can plot 3 and a negative 1. All right, y'all, so let's go to MathLab and plot 3 of these points. So like I said, I'm going to do my x and y was negative 1 and 1, 1 and 0, and then I had a 3, negative 1. Now remember, since it's a straight line, let's look at the graph. It's going to be a straight line again, so I only got to plot 2 of those points. The reason you pick 3 points is because you can check if you're right or wrong by looking at all 3 of the points. If those 3 points are in a straight line, then you know you picked the right points, okay? And it's just to check yourself. But like I said, I've only got to plot two of these. So I'm going to do negative 1, 1, and then 1, 0, and be done with this, okay? So y'all, let's go to Math Lab. All right, so click the enlarge graph. I'm going to click my line tool. So I'm going to do negative 1 will be left to negative 1 and up to a positive 1. Click that point. My second point was 1, 0. So starting in the middle, 1 would be to the right 1. And then 0, you stay on the line. All right, also, there's that little downhill line like we drew. So save that, and then you check your answer. So since we used it from MathLab on this one, we would actually have little thing tells you did nice work, okay? All right, y'all, questions on that straight line. So just be careful. Sometimes you got to actually solve these, okay? All right, y'all, what's this? Y equals x squared. All righty, y'all. X squared graphs. If x squared is the highest exponent on these x squared graphs make what we call parabolas. Now in MathLab, this thing, I think it has, let me look real quick. Yeah. So in MathLab, this is a 3-point x squared tool. Okay. Now, since there's 3 dots on this, you actually definitely need 3 points on this one for it to graph it. So you can use negative numbers if you want, positive numbers if you want, it don't matter. But y'all realize, no matter what number you put in here, when you square it, it will be positive on this graph, okay? So I'm going to put in a negative 1, 0, and 1 on this one. Usually on my x squared graphs, I always use these 3 numbers because they're small and they're easy to multiply. Now, what you got to realize on this one, if you're using the calculator and you do that negative 1 and square it, you got to put the negative 1 in parentheses when you square it. If you don't put the negative 1 in parentheses, it'll give you a negative 1 for the answer. But y'all listen, a negative 1 times a negative 1 is a positive 1. Okay? Let's put a 0 in. Well, 0 times 0 is 0. Let's put a 1 in. All right, well, 1 times 1 is 1. So when I got a 1 here, I get a 1. Look at these. These graphs are symmetric. Anytime you got an x squared, whatever you get for the negative numbers, when you square them, you're going to get the same thing for these positive numbers. So if you put a negative 2 here, negative 2 times negative 2 would be 4. Well, positive 2 times positive 2 would be a 4. So they are really symmetric on these graphs, okay? All right, y'all, so let's go play with that one on Math Lab. All right, so I'm going to click the enlarge graph. All right, so you want the first tool on the second line. So they call it a 3-point quadratic tool. So click that. So a quadratic is because it's got that x squared in it, okay? So plot your 3 points. I had negative 1, 1. So I'm going to go left to negative 1, up to 1. I had 0, 0. So that would stay right in the center and click enter. And then I had 1, 1. So right 1, up 1. And y'all, there you go. You get a U-shaped parabola on that thing, okay? Okay, and then like I said, once you're done, you can check the answer over here and go to the next question. All right, so we got y equals x squared plus 3. This one is still quadratic because you still got the x squared in it. So you would come and make you a table again. And y'all, I would still use the same 3 numbers I had, negative 1, 0, and 1. Now, since I did that by hand up here, I'll show you on the calculator for this one. So go to y equals, clear that out. So x squared plus 3 would be x. If you look over here on the left side, there's an x squared button right there. So hit it and then put in plus 3. All right, so I'm going to look at the points. I'm going to hit second graph to look at the table. And y'all let me arrow up just a little bit so that y'all can see the symmetry on this. So at negative 3, you get a 12. Down here at positive 3, you get a 12. Negative 2, you get a 7. Positive 2, you get a 7. These x squared graphs are definitely symmetric, okay? All right, so the points I'm going to plot are going to be 0, 3. Well, hold on, I want that negative 1. Where's that at? So negative 1, 4. And then my 0, 3. And then my 1, 4. So that'd be using the negative 1, 0, 1 that I had. Now, y'all, let's hit graph and see what the graph looks like. We know it's going to be a U-shaped parabola. And there you go. So it looks like it sort of moved it up a little bit, okay? So let's go to MathLab and graph this. All right, so we're going to click to enlarge graph. It's that U-shaped parabola, 3-point quadratic tool. And I had a negative 1, 4. I had a 0, 3. And then I had a positive 1, 4. So when you draw that last point, it sort of really curves it up for you there, okay? And then you just save it, y'all, check it, and then move on. All right, now this one, you see you got 4 graphs here. This one, I'm just going to go straight on my calculator and graph this one. So let me go to y equals, clear that out. So it's a fraction, so I got a negative. Now to make my fraction, I'm going to hit the alpha y equals and enter. And y'all, that is a 5 on top and a x on the bottom. All right, so I will say this. This graph will either be B or D, okay? And I'll show you why that's happening there. So y'all, let's hit graph. So if you notice, it looks like it's going to be D, okay? So let me show you what they're doing to get that. All right, y'all, so that was what, negative 5 over x. All right, so I'll show you how you get one of them pictures. Um, well, guess what? You can't use a zero for this one. Okay, because if you put a zero in here, -5 divided by zero, you can't do that. We're not able to divide by zero, so this thing is undefined. So we're not able to use a zero for this graph. That's why that graph didn't cross over the y-axis there, okay? So I would use numbers like 1, 2, 3, just to show you what's happening here, okay? So if I put a 1 in here, I get -5 over 1 is -5. And if I put a 2 in there, well, -5 over 2, you can't do nothing to that, so that's going to stay a -5 over 2. Same thing with a 3. If you put a 3 in there, you can't do nothing with that, so that's going to stay a -5/3. Well, what's happening is this is getting smaller and smaller, right? Um, if you put a 5 in it, it would be a -1 there. So it's getting smaller and smaller as you go to the right. So that's why we picked this graph that looked like that. And then see these negative values are getting smaller and smaller. So it started at -5. And then, they're just getting smaller and smaller as you go to them negative signs on that. So when we looked at the math lab here, we would go with D on that one, okay? Now they just got this one thrown in here so you can get good on the calculator. We will learn this kind of graphs in our third week of class, okay? All right, y'all, let me ask y'all this. What's this bars mean? This graph has bars around that x minus 7. Do y'all remember what those are standing for? Oh, good job, y'all. Absolute value. Good job. Perfect. Definitely absolute value. So let me tell you this. Since this is absolute value, those graphs are going to look like a V and it has 2 points on it. So this is a 2-point absolute value tool. But y'all, here's the kicker. We have to draw this point first. We must graph the vertex point first. Okay? Now, what you'll do, this point will be whatever number makes this equal 0 in here. So the first x must make the expression equal 0 inside the absolute value. So, what x value will make that equal 0 inside there? That's what we got to figure out to get our first x value on this. And y'all, that would be a 7. 7 minus 7 is 0 inside here. So if you want to be able to plot this point first, It's got to be whatever number will make that equal 0 in there, okay? So let's put that in. You would have y equals absolute value 7 minus 7. Well, 7 minus 7 is 0. And then the absolute value of 0 is 0. The first y value has to be 0 on this, okay? After that, once you got that point, it don't matter what your second point is. You could use an 8. So let's put an 8 in there. That's going to give me the absolute value of 8 minus 7. Well, 8 minus 7 is 1. And the absolute value of 1 is a 1. Now, y'all, what if y'all would have put a 6 in here? I just want to see what y'all remember about absolute value. Say you would have put a 6 in here instead of an 8 like me. You went with a 6. Well, 6 minus 7 is a -1. But y'all, what's the absolute value of a -1? So definitely a 1. Good job, y'all. So absolute value always comes out positive, okay? So these ones are sort of symmetric, but it ain't the opposite numbers. They're just sort of make that V shape, okay? So we're going to go plot 2 of these points here and see what this graph does. So I'm going to go back to MATLAB. I'm going to click to enlarge my graph. On the top right, absolute value tool, I'm going to click that. So y'all, my first point was 7, 0. Your first point has to be on the x-axis, okay? And then my second point was 8, 1. So let me go over to 8 and up to 1. When you plot the second point, it makes a V-shaped absolute value graph for you, okay? All right, so let me go to let me go back to my um, phone again, or my calculator here. Oh, that went worse. I'm trying to focus in on it, y'all. Okay, right there. All right, so I'm on y equals, I'm going to clear that out. So absolute value, to get absolute value, you hit this math, arrow right until number is highlighted. When number's highlighted, the very first thing you see, ABS, whoops, ABS, that is absolute value. So you hit enter. It'll bring it up here, and then you can put in your X minus 7. All right, so remember, I went to math, and then I arrowed over to number. All right, there you go, X minus 7. So if you hit graph, oh, there's our graph. It went over to the right and makes a V shape, okay? All right, y'all, so remember, to get absolute value, hit math, arrow right until the number is highlighted, and then you see ABS there, okay? All right, y'all need to check that one and move on. All righty, y equals x cubed minus 3. All right, y'all, this one, when we graph this, this is a cube. These cubics use a 4-point cubic tool. So we need to find 4 points for this one. Now, cubes, that cube makes these numbers big. So I'm going to use a 0. I'm going to use a 1. I'm going to use a 2. And then I'm going to actually pick a -1. I'm trying to keep my y value small. If you use a 3 here, that's 3 cubed. 3 times 3 times 3, that is 27. And then 27 minus 3 would give you 24 for the y value. These graphs are only going out so big, okay? If you put a 4 there, 4 times 4 times 4 would be 64. And then 64 minus 3 would be 61. Whew, those are big numbers, okay? So I would use numbers like 0. 0 cubed. 0 times 0 times 0 is 0. And then 0 minus 3 would give you a -3. If you put a 1 in here, 1 times 1 times 1 is 1. 1 minus 3 would be a -2. If you put a 2 in, 2 times 2 times 2 is 8. 8 minus 3 is 5. And then how about this -1? -1 times -1 times -1 is a -1. And then -1 minus 3 is a -4. So negative numbers will stay negative if they got odd exponents, okay? Negative numbers became positive if these are even exponents. Like that x squared I had a while ago, those negative numbers turn positive, okay? So odd exponents, negatives will stay negative. Even exponents, negatives will become positive. Hey, I got 4 points here I'm about to plot on that graph. So let's go to MathLab and plot our 4 points. Well, actually, let me go back to, let me show you on the calculator here. So we'll go to y equals, so that is x. Now the cube, you use this little arrow up key over here, put in your cube, and then arrow right to come back down, and then put in your -3. All right, so let me hit the second graph to go to my table. So y'all look at these numbers. -30, -11. There's -1, -4, what we picked. 0, -3, 1, -2, 2, 5. But then look at these. 3, you got 24. 4, you got 61. 5, you would be plotting 122. So those numbers are really huge, okay? So on a cube, you want to really use small numbers. All right, y'all, watch this graph. There's that squiggly line going uphill to the right. So let's go graph this in MathLab. First, I'm going to click to enlarge my graph. On the second line, I'm going to pick the 4-point cubic tool, and then we'll start doing my points. So I got 0, -3. I had 1, -2. I had right 2, up 5. And then I had a -1, -4. And it makes that little squiggly line for us. So save that and then check your answer. So I won't do this last one. It's another one of those x squared graphs. So we done did a couple of those. So remember, pick 3 points on this one, and it's going to use the U-shaped parabola tool, okay? So y'all all get my um, phone app by tomorrow, my desktop app on that. I'll get that by tomorrow so that I won't have this blurry looking calculator trying to show it on my phone, okay? All righty, y'all. So what we're going to do, I'm going to pause this for a and then I'm going to share my screen. All right, y'all. So like I said, 2.2 is going to deal with functions. Okay, so what we'll start out doing is trying to determine if a correspondence is a function. Um, we'll learn what that is. Then we'll actually do what we call function notation. And then it ends up doing the vertical line test. So the first thing is a function. So y'all, the definition of a function is a correspondence in which each member of the domain. Now, y'all, in here, when I talk about domain, I'm talking about the x values. So a correspondence is going to be one in which each member of the domain has one and only one member of the range. And when we talk about range, we're talking about y values. So basically what this means is that the x values can only have one y value. Okay? X values. You're going to look at the X value. Does X value only have one Y value? If it does, then it's a function. If it's got more than one Y value for a X, then it is not a function, okay? So for these examples, we're going to determine whether the correspondence is a function. All right, y'all. So the correspondence they got for the first one, they're going to give me a domain over here and a range. So for the domain, I got 15, 6, and 13. The range values are 17 and 20. So the 15 points to the 17. The 6 points to the 20. And then my 13 points to the 17. So the question of the day is this correspondence a function? Which means that each of these x values over here, since these are my domains, that each of my x values point to only one y value. So remember, these are your x and these are your y. Well, y'all, let's see. 15 only points to one y value. 6 only points to one y value. 13 only points to one y value. So for this problem here, this would be yes, a function. Okay? So y'all, what we're going to do, let me pull up 2.2 here. All right, y'all, so I'm going to share my screen, and then we'll see if these things are functions or not, okay? All right, so what do y'all think on this one? Is this correspondence a function? 16 is pointing to 24, 3 is pointing to 19, and then 12 is pointing to 24. So y'all, that is definitely, what you got, Jasmine? Yes, perfect. So you'll check that. All right, y'all check this one out. Is this one a function? -1 points to 2, 5 points to 2, and the 8 points to 2. So let me ask y'all this. Does each of these x values only point to one y value? So good job, Claire. They definitely do, right? Each one of these domains only has one y value. So this is definitely a yes. And we're going to put, let's see what's A got. Yeah, because each of the domains only goes to one range. So Monty, perfect. That would definitely be a A on that one. So you start with the domain, not the range on these, okay? All right, let's see what y'all do on this third one. All right, y'all look over here. You got your domains and your ranges, 25, 16, and 9. And then the ranges are 5, -5, 4, -4, 3, -3. Is that a function? Good job, y'all. That's a no. Because 25 is pointing to two different ranges. 16, it's pointing to two different ranges. And then the 9 is pointing to two different ranges. So you start with that domain, and since it's going two places for each of those numbers, that is definitely a no. Oh, y'all, one more. It's about some ball teams here. So what y'all think on this one? Is this a function? Chicago is pointing to the Bears, Bulls, and Cubs. New York is pointing to the Knicks, Mets, and Giants. So each of these domains is pointing to three ranges. Well, y'all, that violated what y'all said. So good job, y'all. Y'all are saying no. That is definitely a no, okay? All right, y'all. So let me get back to the next topic. So y'all just remember, to be a function, the x's can only point to one y value, okay? So Monty, that is perfect. The domain can only be pointing at one range to be a function for those, okay? All right, y'all. So next we get into what we call function notation. And by function notation, I'm talking about f of x. Now, basically, basically f of x is the y. So f of x and y are the same thing. Here's the difference though. In f of x, in function notation, we are given the variable. So we're given the variable inside the parentheses. So f of x, this means my variable is x, and then f is just the name of the function, okay? So you'll see a lot of times the letter they use in function notation, if you get into the sciences, it sort of describes what the formula is for, okay? Like in science, F would probably stand for force. Um, you might have other formulas for, say, power might be a P here or something like that, okay? Acceleration might be a A. So in science, depending on the formula, what it's for, would determine what this letter might be. Now, inside the parentheses is always going to be what the variable is. Now, I will say in your science classes, instead of X's, a lot of times they'll use a T for time. Um, but in here, it lets me know that the variable is the X, okay? Now, here's the difference. So, if I'm given a function, if they put a number inside the parentheses, so if a number is given inside the parentheses, then that number is used to replace the variable in the expression. So if I had a function and it was like f of 3, that means I would put a 3 in for the variable in my expression and then evaluate it. Okay? Now, the f of x, we never do nothing with that. That just lets us know that we have a function, okay? And like I said, if there's a number there, then that number is what we're going to put into the function when we evaluate it. So y'all let me play with a few of these. So for this example, I'm given the function h of x equals x plus 9. Then it says find, they want me to find h of 0, h of a negative 2, h of a negative 4, h of 2, and h of a b plus 20. So this is 5 little problems in one, basically. So they want me to start with h of 0. So here's my expression, h of x equals x plus 9. So see the x here in parentheses is letting me know that my variable over here is the x. So let's start with h of 0. So h of 0, I'm going to take this expression here and put a 0 in for the x. So that's going to give me a 0 plus 9. Okay, right? So I put a 0 in, I get 0 plus 9. And if you add 0 plus 9, you get a 9. So that means h of 0 equals 9. We don't do nothing with this side. This side, they're just telling me that they're putting a 0 in for that x is all, okay? So y'all, how about this one? H of -2. Well, this time they want me to put a -2 in for the x. So I get a -2 plus 9. All right, y'all, so let's see. -2 plus 9 is a positive 7. All right, I got an h of a -4. So since the -4 is inside the parentheses, we're going to put that in for the x. And that's going to give me -4 plus 9. All right, y'all, -4 plus 9. Unlike signs, so subtract the smaller number from the larger. 9 minus 4 is 5. And then give the sign of the larger number. So since my larger number is positive, that's going to be a positive 5. All right, then I got h of 2. So put a 2 in for the x. That's going to give me 2 plus 9. All right, y'all. So let's see. 2 plus 9, that's what's that, 11? So y'all, let's see what y'all do to this one. That is the h of a b plus 20. So since that b plus 20 is inside the parentheses, that b plus 20 will go in for that x. So you're going to have b plus 20. That's the x, and you still got plus 9 on that. So y'all, let's see. What can you do to that? Well, y'all, oh, perfect, Jason, perfect. The only like terms are the numbers. So the b has to come down, and then 20 plus 9 is 29. So y'all remember, these go back to like terms. Once you put that b plus 20, at that point, all you can do is add your like terms and be done with that thing, okay? So good job, Jason. Perfect. Hey, also, we're going to do some more of these. Let me see what's next. All right, y'all. So let's see. On this one, we're given g of r equals 5r plus 9. So they only want me to find 3 on this. They want me to find g of 2, g of -5, and then g of 6.9. So I'll probably use my calculator for that one since it's a decimal. Okay, so there's 3 of these. So we're going to do this 3 times. So g of 2. Y'all, you're going to take this and put a 2 in for the r. So let's see what that gives me. 5 times r, which is 2, plus 9. All right, y'all, so what y'all getting on that? All right, perfect. 19. 5 times 2 is 10. So you get 10 plus 9, which is definitely 19. All right, so y'all got a g of -5 next. That's going to equal 5 times -5 plus 9. All right, let's see what we got here. 5 times negative 5 is going to be a negative 25 plus or 9. And y'all, what's that? Negative, what you got, Amani? Negative 16, perfect. Okay. All right, so the one y'all got to figure out for me is this one, G of 6.9. That's going to equal 5 times 6.9 plus 9. So money, what's that equal? Looks like what, 43.5. Looks good to me. So y'all, that's the trick on these. You're just plugging numbers in. Whatever they got for the number, you're just going to plug it into your little expression and work it. You only work the right side of these, okay? This side, they're just telling me that you got a function, and if there's a number here, they're just telling you what number you're putting it in, okay? Other than that, that GNR don't do nothing, okay? All right, also try this one. Given f of x equals x cubed. So there's 6 of these. We're going to find f of 0, f of negative 1, f of 5, f of 7, f of negative 6, and then f of a negative 4a. All right, so we got 1, 2, 3, 4, 6 of these. So y'all, let's start with f of 0. What, do you want me to put a 0 in for the x? And y'all look at that. 0 times 0 times 0 is a big 0. F of negative 1. That's going to be negative 1 cubed. So remember, a negative to an odd exponent will stay negative. And then 1 times 1 times 1 is 1. So that will stay a negative 1, okay? All right, y'all try this one. This one's for y'all. F of 5. That's going to equal 5 to the third. Now notice, I don't have to put the even numbers in parentheses, but I definitely need to put these negative numbers in parentheses, okay? And not so much on the odd exponents as the even ones, but I always put negatives in parentheses so that I don't lose that sign, okay? All right, Jasmine, good job. 5 times 5 times 5 is 125. All right, y'all, we got an F of 7. That's going to equal 7 to the third power. Now, y'all, we'll say this on these, your calculator, that when we had like 5 to the third, if you'll do 5 and use this arrow up key and put in your 3 and hit enter, that'll give you them answers, okay? All right, so what was 7 cubed, Jesslyn? You got a 343, perfect. 7 times 7 is 49. 49 times 7 is 343. All right, y'all, f of negative 6. That's going to equal negative 6 to the third power. All right, so negative 216. Perfect. And y'all look what's left. F of a negative 4a. That's going to equal negative 4a cubed. So this whole thing goes in for the x, and we're cubing it. Now, it is a negative number to an odd exponent, so it will stay negative. And y'all, here's the thing. You got to cube everything. That exponent affects that, and it affects that A. So it's definitely the negative 64 I like. But now think about this. You got an A times the A times the A. So since I got an A times an A times an A, I'm going to get a negative 64 A cubed. So y'all, technically what we're doing on the variable, remember, since the A don't have an exponent, it's understood to be a 1. So what you're doing on the A, you're multiplying 1 times 3 and getting the exponent of a 3 on that, okay? All right, y'all, so let me show y'all in what we call an application of doing this. So y'all, they're giving me this function f, given this formula. F of c equals 9/5 c plus 32. Have y'all ever seen this formula before? Oh, okay. So y'all, let me tell you what this formula does. This formula finds the Fahrenheit temperature given the Celsius temperature. So if I know my Celsius temperature, I plug it in for the C and work this out, and that gives me the Fahrenheit temperature. So what they want me to do on mine is find the Fahrenheit temperature equivalent to 10 degrees Celsius. So since they're telling me 10 degrees Celsius, they really want me to find F of 10. Okay? So F of 10 is going to equal 9/5 times 10 plus 32. Now, y'all watch this. You can always put a 1 under the 10 to make it look like a fraction. But this 10, and they're giving you numbers that'll divide here. So this 10 divided by 5 will make that a 2. So that gives me 9 times 2, which is 18, plus this 32. And 18 plus 32 gives me, oh, what is that, 50? So 10 degrees Celsius is equal to 50 degrees Fahrenheit. Now, y'all, Math Lab will already have this here. All you do is put in the 50, okay? Now, y'all, you would have got the same thing. 9 times 10 is 90, divided by 5 would have gave you 18 still. On this calculator here, you can do 9 divided by 5 and then times, what, 10? That still would have gave me the 18. And then you could have added the 32. Um, any way you want to do that, okay? All right, y'all, any questions on those so far? All righty then. The last thing we got to look at. Now let me pull this over. So the last thing we're looking at in this section 2 is what we call a vertical line test. And y'all, this is just another way to tell if something is a function or not. And this is by looking at graphs, okay? So if you're looking at a graph, I can tell if it's a function or not by doing the vertical line test. So this vertical line test says if a vertical line can intersect a graph more than once. So if I'm running my vertical line along a graph and it intersects the graph more than once, then the graph is not a function. All righty, so let me show you what I mean. Oh, so we did some absolute value graphs a while ago. Remember, the absolute value graphs look like a V, right? So let's see if this is a function. So y'all, here comes my vertical lines. So if I had a vertical line here, it don't matter where. You can draw vertical lines anywhere on this graph. But look, this vertical line only intersects it once. This vertical line only intersects it once. No matter where I draw these vertical lines, they only intersect this graph at one point. Okay, so this one is yes, a function. So now what if I had something like this? So what if it was a graph that went sideways like a V? Well, look here. If you draw a vertical line, it intersects it twice. This vertical line intersects twice. This vertical line intersects it twice. Since these vertical lines are intersecting this graph more than one time, this would be a no on that. So y'all, I'm going to show y'all pictures and let y'all determine whether these things are a function or not. Okay? And all you got to do is run you a vertical line. All right, y'all, so let me make this one larger. All right, y'all, first graph. Is that a function? Yes or no? Whoa, y'all are quick on that. See, Jesslyn and Claire, y'all are saying yes. All right, y'all, here we go. Final check says good job. All right, y'all. Let's make this circle bigger. Ooh, that was quick. Yeah, you run vertical lines on that. It's going to intersect this thing a whole lot of times, more than once, right? So y'all are saying no. So we put no in and check that. Good job. Well, y'all answering these so quick, I'm barely getting my picture up. All right, good job, y'all. It'll intersect it twice on that, so that's a no for that one. And they usually got a little squiggly one at the end. Good job, y'all. Yeah, you can draw vertical lines on that. They only intersect at one time, so that is definitely yes, a function. Hey, y'all, so let me stop my share for a second. All right, y'all, so that was basically the 2.1 and 2.2 for college algebra. Um, I'm going to show you a little bit of this. 2.2 had support with it, and I'm just going to show you what to do on that real quick. And it was just to get you ready for some of that function stuff. So let me share the support stuff real quick. Um, all right, y'all. So y'all should be seeing my support up here. So y'all, what's this answer? You got an n minus 6n. What would that answer be? All right, so let me fix y'all on this real quick. So let me go back to my pad. All right, so what I have, n minus 6n. All right, y'all. So here's the thing. What number is in front of this n right here? If there's not a number shown, Justin, what you got, a 1? So that is definitely a 1 there, okay? So let's think about this. Since we're combining like terms, the n will stay an n, but what we got to figure out is what's that number going to be? So what is a 1 minus 6 going to give me? Mackenzie, what you got? -5? Yeah, 1 minus 6 would be -5, and then the n stays the same. So we don't change the variable when we're adding or subtracting. So don't change the variable when adding or subtracting. So n minus n's will stay in. We just got to figure out how many. And that was just 1 minus 6, which gave me a -5. Okay. So we would put that in for that one. So I would put in my -5 in for that one. Then you would check it. And you would be able to go to the next one. Hey, y'all, what about that? 6t plus 15t minus 16t. Same thing, all these are t's, so they are like terms. So what would we do is add the numbers. 6 plus 15 is what, 21? And then 21 minus 16 leaves me a 5, and then my t. Perfect, y'all. So 5t is definitely the answer on that one. So just remember, I'm not changing the variable. I'm just changing how many I have, okay? So we cannot change these variables unless we're multiplying or dividing. All right, y'all said that was what, 5t? So you put in your 5t, and then you check that. All right, this one has a negative and then a b minus 9 in parentheses. So let me explain what they got going here. This is getting you ready for the distributive property. And once again, since that negative don't have a number by it, you would almost treat that like a -1 there, okay? But what you do is you're going to multiply everything inside the parentheses by that -1. So I'm going to get -1 times b, which is a -b. And then how about this? That -1 times that -9 makes that a +9. So if you're subtracting and then you got parentheses, it basically changes all the signs. That went from positive to negative. That went from negative to positive, okay? So treat a minus like a -1 and multiply through those parentheses. So let's see. That one gave me a -b plus 9. So y'all, I'm going to let y'all play with this number 4. See what y'all do here. You got a negative 99u minus 60v plus 16. So y'all play with that one for a second and see what y'all get. Are y'all seeing this now? So I got a negative, and then I got parentheses, 99u minus 60v plus 16. Let's see what Claire got. Negative 99u. So -1 times 99u gave me negative 99u. You got plus a 60v. So negative times negative made that a positive 60v. And then y'all got what, a plus? So where y'all getting that 15 at? Oh, but remember, you're not adding that. You're still multiplying that. So remember, if you multiply that, there you go. You're going to get a negative 16. Okay. And at that point, we don't have any like terms. So final answer. So y'all watch out. You're multiplying, multiply, and multiply. Okay. And then let's see what this number 5 is. All right, let's see what y'all want to do to this one. 8a minus 5a plus 7. All right, y'all, so let me bring that over here. So y'all, let me show you on this one. This 8a is not in the parentheses. So you're going to bring this 8a down. Then this negative is going to distribute through here with the negative. So the -1 times 5a is a negative 5a. The -1 times a positive 7. Negative times a positive makes that a -7. Can I go further? Oh, perfect. Claire found my like terms. So 8a minus 5a gave me a final answer of 3a minus a 7. Good job. So y'all, that's the support. It was just a few problems getting y'all used to distributing negatives and adding these like terms up here, okay? So that's all the support was like 5 little questions like that. 2.1, you had a lot of graphing. And then 2.2 was more dealing with the functions and stuff. Hey, also questions on that.